Good morning, everyone. Today we are here to explore an essential component of modern data science in public policy, model deployment. As politicians and policymakers, you understand the importance of turning ideas and plans into actions that benefit the public. In this session, we will discuss how data science models, developed to address various public issues, can be effectively deployed to serve real-world applications. I will explain the fundamentals of model deployment, outline the process of transitioning from model development to live implementation, and identify the key stakeholders who play critical roles throughout the process. Let us begin by establishing the context. Over the past few sessions, you have become familiar with the data science methodology, which involves several iterative steps from problem definition and data collection to modeling and evaluation. Model deployment represents the bridge between the theoretical work of model development and its practical use in real-world environments. In public policy, this transition is particularly significant. Unlike many private sector applications where the focus might be solely on profit or efficiency, public policy models must operate under stringent standards of transparency, accountability, and ethical practice. The deployment of these models is not merely a technical endeavor, it is a transformative process that directly impacts the lives of citizens. When a model is deployed effectively, it enhances public services, informs government decisions, and ultimately helps build trust between the government and its constituents. At its core, model deployment means integrating a data science model into an operational system where it can produce actionable insights. In simpler terms, after a model has been developed, trained, and validated, the next step is to take it from the laboratory, where it exists as code and data, and embed it into the actual decision-making or service-providing processes of government. This is where the abstract becomes concrete. For policymakers, understanding this process is crucial because it demonstrates how scientific innovation is translated into everyday public service improvements. For example, a predictive model that forecasts traffic patterns can be integrated into urban planning systems to optimize road usage and reduce congestion, thereby improving the quality of life for citizens. The significance of model deployment in public policy is magnified by the need for transparency and accountability. Public trust is at stake, and any failure or oversight in deployment can have wide-ranging implications, both legally and ethically. Unlike in the private sector, where errors might be quickly contained, mistakes in public policy models can affect large populations. Therefore, the process of deployment must include rigorous testing, robust monitoring, and ongoing evaluation. This ensures that the models continue to perform accurately and fairly over time. In public policy, deployment is not the end of the journey, but rather the beginning of a continuous cycle of improvement, feedback, and adjustment. To appreciate the full scope of model deployment in government and public services, it is important to understand the various environments and architectures that support this process. Governments have a range of technological infrastructures, from traditional on-premises systems to modern cloud-based solutions, and often a combination of both, referred to as hybrid environments. Each of these environments comes with its own set of challenges and advantages. For instance, cloud environments offer scalability and flexibility, which are critical when a model must serve a large number of users or process vast amounts of data in real time. However, they also raise concerns about data security and privacy, issues that are paramount when dealing with sensitive public information. In many successful cases, government agencies have deployed models that significantly improved public services. Consider a scenario where a model was used to predict and manage natural disaster responses. Such a model can analyze weather data, historical patterns, and real-time sensor information to forecast areas at risk. By deploying this model, emergency services can better allocate resources, plan evacuations, and ultimately save lives. These examples underscore the transformative power of effectively deployed models. Yet, they also illustrate the complexities involved in integrating these solutions into existing systems and ensuring they operate reliably under varied and unpredictable conditions. Transitioning a model from development to real-world application involves several critical steps. Once a model is built and validated in a controlled environment, the next phase is integration. Integration involves embedding the model into the operational framework of public services, which requires careful planning and collaboration with IT departments and other technical teams. Following integration, the model must undergo thorough testing. This testing is not a one-time activity but a continuous process that includes both initial rollout tests and ongoing evaluations to ensure the model adapts to new data and evolving circumstances. Scaling is another essential component. A model might perform well in a pilot project, but deploying it at a national or regional level involves addressing challenges such as increased data volume, higher transaction loads, and the need for faster response times. A key element in the transition process is establishing reliable deployment pipelines. These pipelines, often built using modern practices such as continuous integration and continuous delivery (CI/CD), ensure that the model can be updated, tested, and redeployed seamlessly without interrupting service. This continuous deployment approach is especially valuable in public policy contexts where conditions and data inputs can change rapidly. Alongside these pipelines, continuous monitoring plays an indispensable role. Ongoing evaluation through monitoring systems allows public agencies to track the performance of a deployed model, catch any anomalies early, and incorporate feedback to refine the model. This iterative loop ensures that the model remains relevant and effective in addressing the public's needs over time. Equally important to the technical process of deployment is the role of key stakeholders. The successful deployment of a model in public policy depends not only on the technology but also on the people and institutions involved. Government agencies are at the forefront, responsible for setting policies, regulations, and the strategic direction for technological adoption. These agencies must ensure that the deployment aligns with legal frameworks and ethical standards, providing a solid foundation for public trust. Public institutions, which are the primary users of these models, play a critical role in operationalizing them. They ensure that the model's outputs are interpreted correctly and that its recommendations are implemented effectively to improve service delivery. In many cases, private partners also contribute significantly to the deployment process. These may include technology providers, consultants, or specialized firms with expertise in data science and system integration. Their role is to support the government and public institutions by providing the technical know-how and additional resources necessary to deploy and maintain complex models. The collaboration among these stakeholders is vital for overcoming the challenges inherent in deploying models in a public sector context. Effective communication and clear delineation of responsibilities help ensure that each party understands its role and works together to achieve common goals. The process of engaging these stakeholders is not merely about technical collaboration, it also involves addressing ethical and legal considerations. For policymakers, it is essential to balance the need for innovation with the imperative of protecting public interests. This means establishing clear guidelines for data usage, ensuring privacy protections, and setting up mechanisms to prevent biases in decision-making. Public trust hinges on the perception that these models are used ethically and that any potential conflicts of interest are managed transparently. By involving multiple stakeholders in the deployment process, governments can create a system of checks and balances that enhances accountability and mitigates risks. As you reflect on the process of model deployment in public policy, consider how this methodology translates into real-world impact. When data science models are successfully deployed, they do more than simply process data, they provide insights that lead to better decisions, more efficient public services, and ultimately, improved outcomes for citizens. Whether it is managing traffic flows, predicting public health trends, or optimizing resource allocation during emergencies, the deployment of these models empowers governments to respond proactively to the challenges of modern society. In summary, model deployment in public policy is a multifaceted process that requires technical expertise, strategic planning, and robust collaboration among various stakeholders. It begins with the understanding that a model is not just a theoretical construct, but a practical tool that can transform public services. The transition from development to deployment involves careful integration, rigorous testing, and continuous monitoring to ensure that the model performs reliably in a dynamic real-world environment. Moreover, the process demands the active involvement of government agencies, public institutions, and private partners, all working together to address ethical, legal, and operational challenges. For you as policymakers and political leaders, mastering the fundamentals of model deployment means embracing both the technological and human elements of this process. It requires a commitment to transparency and accountability, ensuring that every step, from development to deployment, is conducted with the public interest in mind. As you consider implementing these models within your own areas of responsibility, remember that the ultimate goal is to create systems that are not only efficient and effective, but also fair and trustworthy. Looking forward, the deployment of data science models will continue to evolve as new technologies emerge and as societal expectations shift. Continuous learning, adaptation, and collaboration will be essential to navigate this changing landscape. By staying informed about the latest developments in data science and understanding the principles behind model deployment, you will be better equipped to harness the power of these tools for the greater good. Today's discussion has provided an overview of the journey from model development to real-world application, highlighting the key processes, challenges, and stakeholders involved. I encourage you to reflect on how these insights apply to your work and consider the steps you can take to ensure that your initiatives are supported by robust, ethical, and effective data science practices. In doing so, you will not only enhance the quality of public services, but also build a foundation of trust and accountability that is essential for successful governance. Thank you for your attention. I look forward to our continued exploration of how technology can serve public policy and to the innovative ways in which you will apply these principles in your own leadership roles.